Good morning, students. Today we are going to start the next part of motion of class 9, that is circular motion. Myself, Pandav Science faculty of your school. Today we are going to start the chapter circular motion. As the name suggests, what do you mean by circular? When a body used to move, in a circular path and body is moving. Suppose a body is moving. This circular region it is moving, then it is known as circular motion. Now, first concept that you have to read in the circular motion, that is angular displacement. What do you mean by angular displacement? Actually, this angular displacement is denoted by theta. Now you will try to understand what is angular displacement. Suppose that a body is moving. Suppose a body A is moving and just now it is making an angle theta 1. Just now body is making an angle theta 1 with the base. After certain time it reaches to point B. Now this is making angle theta 2. Now while moving from A to B, it covered certain distance that is denoted by S. That distance from here to here, distance is denoted by S. And we know that this radius is R. R is the radius of the circular region. Now, angular displacement, that is theta, that is how much distance we have covered from A to B with an angle theta 2 minus theta 1. So, it will be denoted by arc length upon radius. What is arc length? This SAB, the distance that is AB, it is called arc length. So arc length is S and radius is R. So we can say that theta is equal to S upon R, that is angular displacement. What will be the unit of the angular displacement? Unit is radian. It is denoted by rad, R-A-D. Radian is the unit. Now, after angular displacement, we have to learn about angular velocity. Now, after that, we are having angular velocity. After angular displacement, we are having the angular velocity. Angular velocity is denoted by omega. Angular velocity is denoted by omega. This is symbol of omega. It is not W, it is omega. That this omega, angular velocity, can be defined as the change in displacement upon time. What is displacement here? Angular displacement. So it is angular displacement upon time. Ratio of displacement upon time. Velocity is displacement upon time. So what is angular velocity here? Theta time is t. So we can say that angular velocity is equal to theta by t. Angular velocity is equal to theta by t. Now, after angular velocity, you have to learn about angular acceleration. Angular acceleration. What do you mean by angular acceleration? Angular acceleration, just like that. Old acceleration, what we have? Change in velocity upon time. We know the formula of acceleration, change in velocity by rate of change of velocity is known as acceleration. Now, angular acceleration means rate of change of angular velocity. It is denoted by alpha. Rate of change of angular velocity, you can say omega 2 minus omega 1 upon t. This is angular acceleration. This is angular acceleration. If omega 1 is very small, then we can say that angular acceleration means w2 upon t. If w1 is very less than w2. So this is the formula of angular acceleration. Now, after angular acceleration, you have to know about relationship between linear speed and angular velocity. Linear speed and angular velocity. Now, let us linear speed and angular velocity. Relationship between angular speed and linear speed and angular velocity. Here we know that what is omega. Angular velocity we have to take. Now we have to take angular velocity. So what is angular? Omega is equal to theta upon time. We know that omega is equal to theta upon time. That means angular velocity is equal to angular displacement upon time. Now we can write 1 by t multiplied by theta. Okay. Now here it is omega. Now what is theta here? Theta is equal to s upon r. So in the place of theta, we can write 1 by t multiplied by s upon r. It is omega. Now omega is equal to distance by time, s by t, s by t, s by t means v, and we are having the r in the. So we will get v is equal to omega r, where v is known as linear speed, omega angular velocity, and r is radius. Now here, what is the unit of angular velocity? We are having an angular velocity. Unit will be radian per second. What is the unit of angular acceleration? We are having the unit, that is radian per square second. Radian per square second. So what? Now we are having the v equal to omega r. Okay. Now we have to provide a relation between linear acceleration and angular acceleration. Linear acceleration and angular acceleration. As we know that v is equal to omega r. We know that v is equal to omega r. We know that v is equal to omega r, linear speed. From this speed we have to take the linear acceleration. How you will take? So what you can do? Acceleration means rate of change of velocity. Acceleration means rate of change of velocity. So if we will put here delta v, then it will be delta omega r. Delta means rate of change. Delta means rate of change. Delta means rate of change. Now put in both sides, we can divide it by t. We can divide both sides by t. Then what we will get? Delta v by t we will get velocity upon time, that is acceleration, and omega upon t, delta omega upon t. What we will get? We are getting angular acceleration. It is angular acceleration and r. So simply we can say that linear acceleration is equal to product of, we can say linear acceleration is the product of angular acceleration and radius is the product of angular acceleration multiplied by radius. One more thing, student, what you have to take care, while moving in a circular region, what is constant, what is accelerated? While moving in a circular region, in every instant we are changing the direction. At every instant we are changing. When we are moving from one part to, at every instant we are changing the direction. That means v is variable. V is variable. Speed we can say. Speed can be constant. Speed can be constant, but v is variable. That's why circular motion is said to be accelerated motion. Circular motion is said to be accelerated motion. Now, once we will revise. Now, what we have learned today? We have learned about the circular motion. When the body is moving in a circular region, it is said to be circular motion. After that, we have learned about the angular displacement. Angular displacement is equal to arc length upon radius. So we are taking arc length s upon r. Angular velocity is equal to angular displacement upon time. Angular displacement is theta, and time we have taken unit, it is radian. Angular displacement unit is radian, it is radian per second, it is radian per square second, just in the place of meter. In displacement we are taking meter, now take radian. In angular velocity we used to take meter per second. In velocity we used to take meter per second, now take radian per second. In our acceleration we used to take meter per square second, now take radian per square second. Means only change is that in the place of meter we have to take the radian. What is the difference between linear and angular? Only in linear, everywhere we used to take the meter as a unit of displacement. Here we will take radian as a unit of displacement. Now, angular acceleration, we know that change in velocity upon time. So we have taken, now unit is same. Relationship between linear speed and angular velocity, omega equal to theta upon t. Omega in the place of theta. In the place of theta we have to take, in the place of theta, s by r. Now we are having distance upon time, velocity, and r is already there. Now we have got v is equal to omega r. V is equal to omega r. This is very important formula. You have to remember that. Now after that, relationship between linear acceleration and angular acceleration, we have to look. We know that v is equal to omega r. From here we know that v is equal to omega r. Take delta both side. Delta means rate of change. So divided by t, we can divide both sides by t. We can divide both sides by anything. We have divided both sides by t. Delta v by t, we have got a. Delta omega t, we have got alpha. What is alpha here? Alpha is angular acceleration. This is over. Now student, we have completed all the topics of class 9. In my next video, only I will provide the numerical questions related to chapter motion. So what you have to do, if you want more and more videos, you have to subscribe our channel and press on the bell icon. Anything like, share and comment. You have to comment, you have to put the comment in your comment section if you have any doubt or any problem. Be safe, stay at home, and one more thing student, be alert. One last thing I want to tell all the students, that be alert. Lockdown period is going on. Surely this school will not open for more than 1.5 months. it will take a lot of time. So don't waste your time, utilize your full time. We and our faculty members are with you. Thank you.